All right, let's jump right in. We are heading back to March of 1989, looking at a document from CERN written by a guy named Tim Berners-Lee. And look, this isn't just some dusty old proposal. This is the actual blueprint for something that would, completely change the world, the World Wide Web.
But before it could change the world, it had to solve a very real, very specific problem. Just imagine for a second you're at CERN, the European Organization for Nuclear Research. You've got brilliant people everywhere, incredibly complex experiments running, and just a sea of data. How in the world do you keep all of that straight?
And this wasn't some hypothetical question they were tossing around. No, this was the real deal. As the document itself says, this was the question that would just stop conversations in their tracks. It was the big, unsolved puzzle of doing big science.
Now, to really appreciate the solution, you have to understand the sheer scale of the problem. Berners-Lee called it an information black hole, a place where incredibly valuable knowledge was just constantly vanishing.
You see, the proposal describes CERN not as some neat top-down company, but as a web of creative people. The problem? People were always coming and going. The average stay was only about 2 years, so every time someone packed up their desk, a piece of the project's brain walked out the door with them. Technical details would just disappear, and trying to find anything felt less like research and more like a detective investigation.
And here's the really frustrating part. The information wasn't actually gone. It existed. It was recorded somewhere, on some computer, in some file. It just couldn't be found. The connections between all the pieces were completely missing.
So why were their existing computer systems so bad at this? Well, the proposal points a finger at a really basic design flaw. See, most information systems back then were built like trees. And as it turns out, trees are a pretty terrible way to organize complex, messy, real-world knowledge. Okay, so look at the left side here. You've got the classic tree structure. It's rigid, it's top-down. A perfect example is the file system on your computer, right? A file can only live in one folder at a time. But our brains, in places like CERN, they don't work like that. They work like the web on the right. Everything is connected in all these different, flexible ways.
The document gives this perfect real-world example of the problem from a system they used called VMS/help. Let's say you're looking for info on compiler pragmas. So you follow the branches, you're digging deeper and deeper into this tree structure, and you think you're finally about to find what you need. And boom, dead end. The system tells you to go look somewhere else, but there's no way to just click and go there. You literally have to back all the way out of the system and start your entire search over from the beginning. It was just maddening, because in the real world, those two topics are obviously related.
So the alternative that the proposal offered was just beautifully simple. Instead of trying to force all this information into a rigid tree, what if we built a system that worked the way we actually think and work? What if we could connect related ideas directly? What if we just started thinking in links?
The whole system really boils down to two simple concepts. First, you have the node. Just think of it as a circle, a single piece of information, a person, a document, an idea, anything. Then you have the link. That's the arrow that connects two nodes and, crucially, describes their relationship. And that's it. The whole idea is just circles and arrows.
And this super simple model is unbelievably powerful. This table here, it's straight from the proposal, and it shows how nodes and links can describe almost anything you can think of. In a family tree, the nodes are people, and the links mean is the parent of. For a software diagram, nodes are modules, and the links mean passes data to. It's like a universal language for explaining how things relate to each other. Now, this powerful idea of linked information wasn't totally brand new. In fact, it already had a name, one that was coined decades earlier, but was just waiting for the right moment and the right tech to come along: hypertext. And Berners-Lee himself had been kicking this idea around for years. Way back in 1980, he'd written a little program for himself called Inquire that did exactly this. It just let him create links between his own notes. The 1989 proposal was the moment that this little personal tool grew up into a vision for a system that everyone could use. So what is hypertext really? The proposal offers this gorgeous, simple definition. It's not about complex graphics or fancy tech. It's just human-readable information linked together in an unconstrained way. And that word right there, unconstrained, that's everything. That is freedom from the tyranny of the tree.
Okay, so this was way more than just a cool theory. The document actually laid out a clear, practical vision for how to build a real system, one that could start as a tool for CERN and then grow into something, well, something much, much bigger.
For this to work, the proposal said it had to meet 4 crucial requirements. First, remote access. It has to work over a network. Second, Heterogeneity. It has to work on all different kinds of computers, Macs, Unix machines, you name it. Third, and this one was absolutely revolutionary, non-centralization. This meant anyone could set up their own server and link to anyone else. No central boss, no gatekeeper. That was the secret sauce that allowed it to scale. And finally, it had to be able to access all the data that already existed.
But hold on. How do you get people to start using a totally new system when all their important stuff is stuck in the old ones? Well, here is the proposal's killer idea, the gateway concept. The idea was to build one piece of software, a browser, that could not only read all these new hypertext documents, but could also act as a kind of magic window into all the old existing databases.
This meant the system would actually be useful on day one. A browser could tap into the newsgroups, the CERN document system, existing file systems on computers, even something as simple as the CERN telephone directory. It could take all these separate islands of information and weave them together into one single searchable web.
And the proposal doesn't end with a bunch of technical details. It concludes with this big philosophical call to action, a vision that, honestly, still gives me chills today.
Right from the very beginning, the focus was on making this thing universal. The whole point was to build a system that was open, that was accessible, that worked for everyone, on any machine. It was always about function over flashiness. It was about generality over proprietary bells and whistles. And that core principle, that is what allowed the web to grow into what it is today.
Decades later, here we are. We are literally living inside the world that this proposal imagined, a world built on links. But it kind of leaves us with this huge, fascinating question. This document connected documents and data. As we're looking ahead at things like AI, the Internet of Things, and all these new digital worlds, what are the next essential things that we need to connect?